what's the property they all have in common to be a member, this ordered pair, to be a member of the set, in other words this language? Well, that M accepts W. Right? Whereas R here, it will decide this language, and the ordered pair in this language is that, of this, it looks like this, but there's a difference, and machine M, Turing machine M, halts on W. Okay, so let's see. So your S has to decide this, decide. So if, now a decider, remember, is some Turing machine that accepts all strings of the language and rejects all strings that are not in the language. Right? It's a decider. In other words, it halts. It accepts or it rejects. There's no looping. Okay. So that's what S has to behave like. Okay. So if your S, you'll have to output accept if M accepts W, and you'll have to output reject if well, otherwise, right? Because you have to decide. S is a decider. So you'll reject, and there's two possible ways you could reject, is that this M here, either it loops or it rejects W. Okay? That's what your S has to do. Right. So how to go about constructing S? What would you do? Well, one idea, I'm talking ideas now, one is that you have S simulate M on W. So if M accepts or rejects, that's fine. Just have S do the same thing. Okay, that's fine. But there's a problem. Okay, but what happens? You might not be able to determine if M here is looping, right? Because it might just be taking a hell of a long time to halt. Right? It may eventually accept or reject, but it may be taking so long you don't know whether it's looping or not. It's a classic problem about Turing machines, right? So if you decide this idea, if you run with this idea of simulating, having S simulate N with the input W, then you're going to have a problem because your simulation may not terminate. Right? And that's a bad idea, because if your simulation's not terminating, because your S, you remember, S has to decide this. Decide means it halts. Right? Decide means to accept or reject the members of this language. So if you're just hanging around forever, that's not deciding. That's a bad idea. So that idea, just simulating is not a good idea, because S is supposed to be a decider. It's not allowed to loop, right? So this idea, it's not, so therefore this idea by itself doesn't work. All right, what to do? You're stuck. So what can you do? Well, we can use R. Remember saying earlier the idea that we can construct S that calls on R, that uses R as a part, as a component, and R, you remember, decides on the halt. Now we can use that. That we, by being a bit ingenious, we can use that idea. We can use R to decide on halt to get us around this problem of looping. Right? So we're being smart. We're being ingenious here. So how to do it? So the next idea is so to use. So we're pretending that we ourselves are S. Okay, and so we now. As S, we use R, and what does R do? Well, it decides on halt. Okay, so So we can use that R to decide whether M halts to decide whether M halts on W. Okay? Because that's what R does, right? It decides this language. So anything of this form here that belongs to the halt language, R will decide on it. It will either accept or reject these ordered pairs that belong to this language. Right? It's a decider. It halts. It either accepts or rejects. There's no looping. So by using R, there's no problem about looping. There is no looping because R is a decider. Okay. So use R to decide. So I've got to be careful here. Use R to give you the knowledge whether the ordered pair M, W loops or doesn't loop. Okay. So we're going to use R. So we're S now, and we're using R. So if R says that M does not halt, okay, so that's a reject. So if R rejects this, now remember this is halt. The condition that this language accepts the condition that this language contains this ordered pair is this machine halts on MW. Okay. So any pair here from this language, we can input into R, and R will tell us whether this machine M halts on W. So we can use that. We can use R to tell us whether this string halts on M, right? So if it does, the halt will return accept, and if it doesn't, if it doesn't halt, and R will tell us that's what it does, right? R is a decider. It will tell us. So if some ordered pair that belongs to ATM, if R tells us for that pair that this string does not cause M to halt, well, then we can reject it because this pair doesn't belong to the language ATM. Let me try and, maybe that's not so clear. Let me try and reformulate that so make it a bit clearer. Right, now what does R do? R is a decider. So if you input, it decides the language halt. Okay. So if you input any ordered pair M, W, it will accept or reject because it's a decider. Now if R rejects, what does that mean? R rejects, what does that mean? That means that M will not halt on W. Okay? Now if it doesn't halt, then it can't be, that string W cannot be accepted by M for this language. Now, what I just said is critical. Play it back if needed. Okay. If your W causes M not to halt, well, then there's no way that that MW that M will accept W as a member of this language.